structural reactions. So today we will go through structural reactions and carry on last session. Last session we explained something about the reactions like this. So if we have a beam like this and I have a force, for example, if this one is 3 meters and this is 10 kilonewton on this beam, so I computed the reaction, and we said last session that if we have a symmetry, there is a symmetry here, so the left hand side is symmetric with the right hand side. So as long as there is a symmetry, so this one will be divided into 2 equal parts. That means this one will be 5 kilonewton and that will be 5 kilonewton. Now the horizontal reaction here, because this one is hinge, this one is roller. For roller we have only one reaction, it is in the vertical direction. Here we have 2 reactions in the vertical direction and horizontal. So this one, if we go to this one equals 0. Why? Because sigma fx equal to 0, so we have only this one. There is no other horizontal force, so this one will be 0. Now we will discuss another somewhat more complicated example. Here we have a cantilever beam. You see, this is a cantilever beam. So here it is fixed at point A. Determine the reactions on the beam. The first thing is, here I have, you see, I have AX, AY, and MA. AX being the horizontal, AY being the vertical, and MA is the moment. So AY solution. Sigma fx equal to 0, then AY a plus nothing. We don't have any other reaction, so there is nothing equal to 0. That means this is AX, this is AX. That means AX equal to 0. Okay, now A sub y, you see, A sub y here, this is a trapezoidal loading. So it may be split into 2 parts. One is rectangular and one is triangular. So it is split like this, you see. This one is 5 and this becomes 5. The remaining here is 10 kilonewton per meter. So it has become a uniformly distributed load, which is 5 kilonewton, and a triangular distributed load, which is 10 at one end and 0 at the other end. Now you see, for this one, this is the uniformly distributed. The total force is 5 multiplied by 12. 5 multiplied by 12. We learned how to calculate the resultant force for uniformly distributed. So 5 multiplied by 12, so it is 60 kilonewton. For triangular, it is half multiplied by this value, which is 10 multiplied by 12. So it becomes 60. Now, the point of effect of this uniformly distributed is midway. So for this one, for the uniformly distributed, it is halfway. The resultant is halfway. So this one, 60 is halfway. Okay. This one is 2/3 from the triangular top. So it is from here. Last session, we said if we have a triangular like this, then the resultant will be, it is 2/3 from here. So if this one is H, this one will be 2/3. So the point of effect of this force of triangular section, it is 2/3. So 2/3 multiply by 12. So it will be from here to here. It will be 8. And from here to here is 4. So you see, for uniformly distributed, it is 6 meter. This one is halfway, and this one is 4 meter from the support. Okay, so now sigma Fy equals 0. Everything up is considered positive. Then this one is Ay, it is up. So Ay plus, or it is, this one is positive. So this one, the uniformly distributed, is down, so it is minus 60. This one is also down, it is minus 60 as well. So equal to 0. That means A sub Y equal to 120 kilonewton. Okay. Now calculating M sub A. M sub A may be calculated that the moment about point A equal to 0. So taking all the moments about point A equal to 0, this will give